How's it going, guys? Okay, so today we're going to talk about the solar system, our solar system called the Sol system. We've talked about this a little bit before, but we're just going to kind of briefly go over some of the planets, the asteroid belt, Kuiper belt, and the Oort cloud, and then of course the 8 planets and their moons. But if we're going to start correctly, we should probably look at the most fundamental aspect of the solar system, and that is all of the planets and the sun. So, of course, we have 8 planets in the solar system, and there used to be 9. A lot of you probably are familiar with Pluto. Pluto's a dwarf planet, so Pluto isn't included in our immediate solar system of 8 planets. And all these planets orbit around the sun. The sun accounts for roughly 99% of the mass, the amount of matter in the solar system. So everything is orbiting the sun because of the sun's giant gravitational pull. In the order, we have Mercury, Venus, Earth, Mars. We have then an asteroid belt. We have Jupiter, Saturn, Uranus, Neptune, the Kuiper belt, and then outside of that, we have the Oort cloud. We'll talk about comets and asteroids and those other things that exist within these areas as well. But of course, the sun is the center of the solar system. It accounts for 99.86, so even more than I thought, percent of the mass in the solar system. It's composed of mostly hydrogen and helium, and it produces more and more mass through the means of nuclear fusion. Diameter is 1,392,684 kilometers. That's the distance across the circle, not the circumference, but the diameter. Remember, radius is half of the diameter. Diameter is the total distance across, and circumference is the full length around the circle. It makes it 109 times wider than the Earth. 109 times wider. So you could stack 109 Earths side by side across the diameter of the sun. And that makes it 330 times as large as the Earth. It's responsible for all these gravitational forces that actually keep our planets in orbit. Of course, there's no friction, there's no air resistance in space, so these things are traveling in a straight line, but the only reason why they're now traveling in a circle is because of that gravitational pull, which creates the centripetal force that keeps these planets in motion in a orbit. The inner planets, these are the planets that are closest to the sun before the asteroid belt that exists between Mars and Jupiter. So we have Mercury, Venus, Earth, and Mars. Mercury is the smallest planet in our solar system. It's closest to the sun, about 335 billion miles away from the sun. It's the smallest planet. It's only 4,880 kilometers in diameter, which is only like a third of what the Earth is, the actual diameter. So you can fit 3 Mercuries inside of the Earth in diameter. Atmospheric gases, sodium, potassium. Surface of the planet is mostly iron and nickel. And it moves significantly faster in its orbit around the sun because of its close nature to the sun. The closer you are to the sun, the faster that gravitational pull is going to pull you around the sun. And we'll talk about that later on. But it orbits the sun in 88 days, and it moves about 1.5 times faster than the Earth in its rotation. Next is Venus. Venus is actually the hottest planet in the solar system, and that's because of its composition. You would think that Mercury would be, considering it's closest to the sun, but Venus is actually the hottest planet in the solar system. It gets up to 900 degrees Fahrenheit. It's relatively similar in size to the Earth. It's solid, rocky surface with iron core and lots of craters. And it orbits the sun in 225 days. So its calendar year is 225 days. Atmosphere is full of sulfuric acid clouds and a bunch of CO2, kind of like Mars. The Earth is the only planet we know to support life. We got 1 moon. Our atmospheric gases are primarily nitrogen and oxygen. There's some other things in there as well, but those are primarily the gases that actually orbit the sun. It's the only planet known to support life, orbits the sun in 365 days, and it's in that Goldilocks zone. It's only, because of its habitable conditions, that we have water and nature and plant and soil and all of those things, we're actually able to support life. We're about 93 billion miles from the sun. Next thing we have is Mars. Mars is the only other planet that we've kind of really explored. Like we have rovers there. Diameter of 6,793 kilometers. Very similar. It's bigger than Mercury, but it's closer to Mercury in size than Venus and Earth. Orbits the sun in 687 days, so almost double the calendar year of the Earth. Atmosphere is CO2. This is primarily why we can't live there. It's just because there's no breathing conditions there. The reason why it's red is it's covered in iron oxide dust, and it does have 2 moons and lots of volcanic rock and craters. You then have the outer planets. Jupiter. Jupiter is the biggest planet in the solar system. It's huge. I mean, that's to say the least. So think 12,000 kilometers in diameter for Earth, 142,000 kilometers in diameter for Jupiter. Just a massive planet. Has 67 moons, atmospheric gases of hydrogen and helium, no solid surface. So all of these planets are gas giants. Takes 4,331 days to actually orbit the sun. It moves significantly slower than the Earth. And this is, again, because of the distance away from the sun. You have Saturn. Saturn is the second largest planet. It has this giant ring, right? 7 major rings within that system. Orbits the sun in 10,747 days. Atmosphere is primarily composed of hydrogen and helium, but again, a gas giant 925 million miles away from the sun. If Uranus is roughly 1.83 billion miles away from the sun, 51,118 kilometers in diameter. So that's pretty large as well. All of these planets are much larger than the inner planets, much larger. But again, they're all gas, so they actually have no solid surface. Uranus contains 27 moons. Neptune contains 14 moons, so this is significantly smaller in its system size, but in diameter, it's almost the same size as Uranus. Takes 59,800 days to actually orbit the sun. These are all gas giants. Atmosphere is primarily hydrogen and helium, but the entire planet is primarily composed of gases. So there's no solid surface. You can't walk on these. They're not rocky. There's no oceans, none of that stuff. Okay. We used to talk about Pluto. We're not going to talk about Pluto because, again, it's a dwarf planet. That will come up in the next lesson. Asteroid belt. This asteroid belt actually exists between Mars and Jupiter because there is a great distance between the 2 planets. It's not like what you see in Star Wars where they, fly through the asteroid belt and barely miss asteroids and they're all right next to each other. It's not really like that. They're pretty spread apart. This isn't really an accurate picture. There's actually more distance between them, but there is thousands of asteroids in the asteroid belt. Really irregular shapes. They're smaller than planets, but they're still like the size of minor planets. They're pretty large. They're about 1.3 to 4.2 astronomical units away from the sun. That's the center. Astronomical unit we've talked about before is a measure of the distance between the center of the Earth and the center of the sun, so 93 million miles. All right, so we have the Kuiper belt. The Kuiper belt actually exists beyond Neptune's, right at the edge of Neptune, and right before, and actually a little bit into the orbital ring of Pluto. So it is roughly 30 to 50 astronomical units away from the sun. This is where you would find all the comets flying through the Kuiper belt. Bunch of short period comets, whereas you might find long-term period comets in the actual Oort cloud, which exists beyond the Kuiper belt. Oort cloud is actually kind of 3-dimensional, and it basically is composed of like icy bodies and small comets, and it exists far beyond the Kuiper belt and our solar system. There's a large gap in between. You could see if this is the Kuiper belt, you got to think this is a giant distance out from the Kuiper belt. So that is our solar system in a nutshell. This is kind of the systems that it's composed of. We'll talk more about some of those systems and subsystems later, but this is a nice brief little overview on our solar system. Okay.